So I've decided that I will solve this last, I'm going to prove how we find these values for the 600 Newton case. So we understand intuitively that this should be the case. We understand that if there's 600 newtons and it's divided in a 1:2 ratio, it makes sense that we should get 2/3 on this side and 1/3 on that side. But we're going to prove it by using the sum of the moments method that we saw above. So we're going to replace these again with letters. So we're going to call this, generally the terminology we like to use is we like to call this reaction at A and the reaction at B, or whatever letter we're going to use. So if this is point A, then it's reaction at A. If this is B, this is reaction at B. Some people don't use those terminologies, and that's fine. So like the guy who does the Eureka engineering videos, he doesn't use that terminology, and that's, he uses just A, and that has its benefits. So what we're going to look at here is we have two unknowns, and I don't really care which one I find. I can either find A or B. It doesn't matter to me. But what I'm going to do is I've decided that I'm going to take moments from point A to find reaction at B. That's what we're going to do, just this first time around. So we're going to find the reaction at B. So what we're going to do is we're going to say the sum of the moments measured from location A equals 0. Now, we know this is true of every point, but if we do it from another point, we're not going to be able to eliminate these two unknowns. And so by taking moments about A, we multiply A by 0, and multiplying A by 0 is going to eliminate that value. So I've written RA brackets 0. You don't need to write that, so to remind you that you don't need to write that, I put that in green. Now, the next force we have is 600. So I'm going to write 600, and I'm assuming from measuring at point A, I'm going to spin this moment arm. I'm going to spin it, and we'll see which direction it goes. Okay, that's spinning clockwise. So we're going to turn that into a positive, and we're going to say the distance from A is 1 meter. The next force, I'm going to write down minus RB, and then I'm going to figure out the direction. Okay, so measuring from point A, it's spinning the opposite way. Okay, so it's going this way. So it's just going to go anti-clockwise. It's going to stay as minus, and its distance is 1 plus 2, which we can write that as 3. What we're going to get is we're going to say 0 equals 600 minus 3RB. If I add 3RB, and now I will also say we made an assumption here. We assumed that RB is going up. So I'm going to write here, assume up, therefore anti-clockwise. And at minus 3RB, so I'm going to add 3RB to both sides. I will stop doing that eventually, but I want to make that really clear early on what's happening. So what I'm going to get is 3RB equals 600. And that answer is positive. So I can then write positive, therefore our assumption was okay, therefore it is indeed going up. Eventually, when we do cantilever beams way later in the course, we'll find that the assumptions can be wrong, and we will get negative values. So that's how we deal with those. Okay, so in this case, if we know that if I can buy 3 red balloons for $600, that means that each red balloon is going to cost $200. I say that out loud just because it helps me to do my estimations. And so I'm going to get RB equals 200 up. Now, there's two ways that I can find RA. The first way that I would solve RA is I would say, this is the way I would typically do it, I would say the sum of the forces vertically equals 0. Now, I normally don't like doing it mathematically, but today I'll do it mathematically. I'll say, okay, so RA equals, well, I'm going to assume that RA is going up. So I'm going to say plus RA, and I'll write here, assume up, and we've said up is positive, therefore positive. RA minus 600 because it's going down, plus 200 because 200 is going up. So let's, if I bring this over here, what I'm going to simplify that is I will minus this side. You know what I'm going to get? Here's how I'm going to do. 0 equals RA minus 400. Minus 600 plus 200 is minus 400. Then I'm going to add 400 to both sides, plus 400, plus 400. They're going to cancel out. So what we can say is 400 equals RA. That's positive. Therefore our assumption was okay. Therefore it's up. And then we can say that RA equals 400 newtons up. That's one way of doing it. Another way that's even faster than that is I can take all of this writing out that I just did here. I mean, it doesn't need to be 4 lines, right? But I write it 4 lines just because I want to be really detailed. How I would typically do that is I just look at what are all my down forces. All my down forces, I've got 600 down. What have I got going up? I've got 200 up. So my missing amount is going to have to be the reaction at RA, which I have a tradition of I like to say, RA! Comes from a board game. And so I can say RA must equal 400. And I think that that's okay. I've never seen anyone else do it that way in exams, but someone who I haven't taught do it that way. But I think that that's provided, it's a little vector diagram, it's provided enough information to show the marker what I'm doing there. What we can also do, now, and this is something that people do sometimes do, is that if you finish the exam early and you're sitting there with too much time in your hands, what you can do is you can now calculate RA taking sum of the moments about B. So let's have a look at what that would look like. So if we said sum of the moments relative to B equals 0, 0 equals, well, what have we got? I've got RA, or RA, as I like to say. And first of all, is it going clockwise or anti-clockwise? It's going clockwise, so I can stay positive. I don't need to worry about that. And how far away is it from RB? I'm going to write it as 1 plus 2. And the reason I wrote it as 1 plus 2 is because I'm going to assume clockwise, so that's what's positive. Let's actually assume up. Therefore clockwise. Because it's positive. I like to write it as 3. That helps me to, by writing it as brackets like this, what I see is I see lots and lots of students when I mark other people's work, I see lots and lots of people write it as RA times brackets 1 plus 2, and then I see plus brackets 600 times measuring from B to plus. The thing is, brackets already give you the times. They already do the times symbol for you. So I just found that by writing my times, always writing my times just as these brackets, it makes it really easy to see which part of the question we're in. We can say, oh, that's force 1, force 2, force 3, without having an excessive number of brackets. And the thing is, sometimes I need to do little calculations here in these brackets. So I don't want to have brackets within brackets. I don't want to write brackets within brackets, because it's not necessary. So that's a little bit of I'll only say that once. I tend not to make a fuss over that. That's just how I tend to write things. Okay, so the next force is 600. And remember that the 600 is measured from here to RB, because we're taking moments about B. So that's 2. And then finally we have plus 1. Now, is it going clockwise or anti-clockwise? We're measuring from B, and it's going this way. It's pressing down on the clock arm. So, that's going anti-clockwise, so it's going to stay negative. And I've got RB times 0, and that can stay at 0. So what have we got here? 0 equals 3RA minus 1200 equal plus 0. What I'm going to do, I promise I'm going to stop doing this. 1200, 1200. 1200 equals 3RA. That's positive. So if it's positive, therefore our assumption was okay. Therefore it's up. We can say 3RA equals 1200. Therefore, if we divide both sides by 3, we can say RA equals 400. which is exactly what we worked out earlier. That's exactly what we worked out. But the idea is that if what you've done is correct, this will all work out in the end. So what you can do is you can find RA this way, and if you're just sitting around with too much time at the end of the exam, you can go back and look at this and take the moments from the other direction and see if this holds true. Now I did mention that once we know these values, we can take the moments from any location and prove that they're equal to 0. Now this is not a thing that we normally ever have any reason to do. There's no practical purpose of doing this. This is just to demonstrate this sentence, this mathematical sentence here of the sum of the moments at B equal to 0. So what I'm going to do is I'm just going to prove that by doing one last point, and we're going to measure that from this point here, which we're going to call C. Okay, so if I take, and what we're just going to do is we're going to prove that 0 equals 0. So we're doing clockwise moments are positive. The sum of, so sigma for sum of, the moments relative to location C equals 0. 0 equals, and we're just writing in all our forces, RA, which we said was 400. Now relative to C, how far is that? Relative to C, that would be 1 meter plus 1 meter is going to be 2 meters. So I'm just going to write 2 meters net, just so that you know where that number came from, because it wasn't really apparent earlier. Okay, then, is it going clockwise? Is this force going clockwise or anti-clockwise relative to point C? RA is going clockwise. The next force is 600. Is it going clockwise or anti-clockwise? It is going anti-clockwise. So I'm going to leave that as anti-clockwise, and its distance is 1 meter. That's pretty apparent. And then the last force is RB, which we said was 200 newtons. Is it going relative to C? That force is going up, so it's also going to be going anti-clockwise. And that's 1. Okay. So what we're going to have here is we have 0 equals 400 times 2 is 800 minus 600 minus 200, and those numbers all equal 0. So we've proven that this sentence is true. The thing is, why we do this, why we prove that this value is true, why we say the sentence is true, is because typically what we're going to have is an unknown. We don't care about this unknown because it's multiplied by 0. By taking moments about B, we eliminate that force. We just say it's 0. What we can do is then find this unknown, this RA, and we can move the RA to this side of the equation. When we move the RA to this side of the equation, we can find RA. That's why we use the sum of the moments rule. So those three rules together allow us to solve lots and lots and lots of questions that we're going to do at the HSC level.